February 2026. The technology sector is entering a period analysts increasingly describe as a structural reset. Business models are shifting, legacy platforms are being phased out, and companies that once competed in separate markets are now converging around artificial intelligence, automation, and computational infrastructure. What once looked like gradual evolution is now unfolding at a far more aggressive pace. One of the clearest signals of this shift comes from OpenAI. The company continues consolidating its model lineup around newer GPT-5 class systems, gradually moving away from earlier generations that defined the previous cycle of consumer AI. At the center of current attention is GPT-5.3 Codex Spark, an ultra-low-latency variant optimized for interactive workloads, particularly programming and rapid iteration tasks. The defining characteristic is speed, leveraging wafer-scale hardware architectures. The system reportedly achieves generation rates exceeding 1,000 tokens per second under specific conditions. For developers, this changes the interaction pattern itself. Instead of waiting for model responses, workflows begin to resemble real-time collaboration, code generation, debugging, and structural edits occur with minimal delay, reducing cognitive interruption and potentially altering how software is designed. The broader implication is competitive pressure. As model quality differences narrow, latency, throughput, and cost efficiency increasingly become primary differentiators. In other words, raw performance metrics are emerging as strategic assets rather than engineering details. Parallel transformation is visible at Tesla. After more than a decade in which electric vehicles define the company's identity, Tesla is intensifying its pivot toward robotics and physical AI systems. Production priorities are being adjusted, and manufacturing resources are gradually redirected toward the Optimus humanoid platform. Industry observers note that Tesla's long-term narrative now emphasizes scalable automation rather than purely automotive expansion. The rationale is economic as much as technological. Humanoid robots represent a potentially vast labor substitution market, extending from logistics and manufacturing to service roles. Unlike vehicles, which face replacement cycles measured in years, general-purpose robots could integrate directly into continuous operational environments. Tesla's manufacturing strategy reflects this ambition. Facilities originally designed for vehicle assembly are being adapted for high-volume robotic production. If achieved, the projected scale would place Tesla among the largest hardware AI integrators globally. This shift also reframes Tesla's position in the industry. The company is no longer evaluated solely as an automaker adopting AI, but as an AI-driven robotics company that still operates in transportation. Meanwhile, Elon Musk's X platform continues expanding beyond its origins as a social network. The launch trajectory of X Money illustrates a broader pattern visible across the technology sector: platform convergence around financial services. Early reports describe a system designed to integrate peer-to-peer payments, stored balances, and transactional functionality within the X ecosystem. Partnerships with established payment networks and regulatory licensing efforts suggest an attempt to bridge traditional finance and digital platforms. Strategically, this positions X within a highly contested space historically dominated by banks, payment processors, and fintech intermediaries. Embedding financial infrastructure directly into a high-engagement platform could reshape user behavior by collapsing communication, identity, and transactions into a single interface. The long-term significance lies in control over financial rails. In digital ecosystems, payment layers often determine user retention, monetization flexibility, and data flows. X Money therefore represents more than a product feature. It signals an infrastructural play. Meta is advancing a related but distinct strategy centered on autonomous AI agents. The company's recent model releases and protocol initiatives highlight a push toward systems capable of proactive task execution rather than reactive dialogue. This evolution reflects a conceptual transition within AI itself. Earlier consumer models focused on answering questions or generating content. Emerging systems increasingly aim to initiate actions, scheduling events, coordinating services, or managing workflows with reduced user intervention. Such capabilities depend not only on model intelligence but also on standardized interfaces that allow AI systems to interact with external software environments. Protocol-level developments therefore become critical enablers of agent-based ecosystems. Underlying these visible shifts is a less publicized but equally decisive arena: computational infrastructure. Advances in networking silicon, specialized accelerators, and power efficiency technologies are rapidly redefining the economics of large-scale AI deployment. Gigawatt-class compute clusters, once theoretical, are becoming realistic planning targets. In this environment, performance per watt, interconnect bandwidth, and thermal constraints directly influence which organizations can scale AI systems competitively. Hardware suppliers, semiconductor firms, and energy efficiency innovators therefore play an increasingly strategic role in the AI landscape. Across the industry, a consistent pattern is emerging. AI capability, robotics, financial integration, and infrastructure efficiency are converging into a unified competitive axis. Companies are reorganizing not around single products, but around control of entire technological stacks. What is unfolding is not simply another upgrade cycle. It is a reconfiguration of how digital and physical systems are designed, deployed, and monetized. The pace suggests that the reset is already underway.